Hello everyone, and welcome to the MASTA Hints and Tips webinar. So hopefully you can all hear me and you can all see the screen which I'm displaying to you, which currently has a version of MASTA 10 open on it. Now, this particular webinar is going to be a little bit more disjointed than some of the others. So what we're going to do is just go through some of the available functionality in MASTA that you might not be aware of. So some of the less known things that might help you save a bit of time, might allow you to do things in a slightly different way that are a bit more suitable to your way of working. And it'll be covering a range of areas. We'll be looking at a few things in the settings. We'll be looking at the general user interface. We'll be looking at things to do in design and a couple of things to do with analysis as well. So what I want to start off doing is just looking at a few things that might help you out in the settings menu of MASTA. So the settings menu is accessed in the Edit dropdown from the MASTA window, Settings, and that opens up a new screen. Now there's many options available in here. I just want to draw your attention to a few of those. And the first one is that pesky autosave, which appears quite frequently on your default installation of MASTA. So on your program settings here, I want to draw your attention to this saving option at the top. So I think by default, unless it's recently been changed, the default autosave interval is 5 minutes, which is great when you're making a really simple model that's really quick to save. When you start getting quite a complex model with FE that's integrated into it and maybe quite heavy on the results, for example, 5 minutes, it may be a bit too much of a short timescale because it takes a minute in itself to save the model. So you can change the autosave interval up here to whatever you wish to be, or just turn it off completely if you wish to do so. Another thing to be aware of is the ability to change the measurement units or to change the units within your MASTA software. And this is installation specific. So let's say that you wanted to view something in a certain unit, you could do so, and then as soon as anyone else opened the same model on their machine, which had a different measurement set, they would see it in their set of units. So, for example, if I look on this list here, it's given me an option to select any of the units available in MASTA. So if I go for mass, for example, just to pick one, I can choose the default unit that it wants to use. I can do this for every individual measurement setting, or if I want to do a sort of a global switch from imperial to metric, there's these options down here as well. Also within the settings menu, you can change material defaults. So let's say you're making a lot of new models. You don't want to use the default material in MASTA for everything that you make. Let's say that's not particularly suitable, or you have a generic material in mind or a specific material in mind that you like to use. So if I go to specific areas of the settings, so let's say my gears, or I can go to my shafts, for example, you'll see that we've got various options which allows us to change the default material, which will basically mean that whenever we create one of those components, it will show this by default. So if I said I wanted to change the ISO material of the gears, for example, I could change this in here to whatever I wanted it to be, and then every gear set I make or every gear I make will now be created with that particular material. We can still be adjusted in the design if you so wish, but this is setting the default setting in those in the material. Okay, so also within the settings menu, we can apply design constraints to our model. So this is for cylindrical gear design. So I go down one setting here to my constraints. And what you'll see is that we have a load of different constraint options available. And this basically indicates where you will get some errors or warnings or messages which appear down at the bottom. So there are some defaults already specified. So for example, it's saying that we have an allowable helix angle between 0 and 35 degrees. Anything outside of that will give us a warning and it will tell us that it's outside. We could, however, change that to an error, we could change it to a message, or we can add our own constraints in here as well. So if you've got some particular design constraints, which are, let's say, company specific or slightly different than we've got as our defaults, you can modify them in here. Okay, and the last thing I want to show in here is something that was brought in quite quietly, which is something called push bullet. So this is, it's basically a way of allowing you to know what your analysis is doing whilst you're working somewhere else. It's just basically works in conjunction with an app called Push Bullet, and it basically, whenever your master model finishes an analysis, let's say you're doing a very long parametric study analysis or something like this, you can link master with the app and it will give you a push notification to your mobile, to your cell phone, whenever you have told it to do so. So whenever it gets to a new stage in the analysis or finishes its analysis. Very useful if you're doing some analysis on a remote machine that you're not next to, or you need to go away and do work somewhere else, for example. Okay, so I want to talk a few things now about the general user interface. Now, many of you might already know most of these, but hopefully there'll be one or two little tricks that you're not aware of. The first thing I want to show is the repositioning of the windows and repositioning of the interface. So this is kind of the default view within MASTA. However, all of these windows, all of these areas are fully customizable in where you position them. So I'm in design mode, for example. Let's say I wanted a view of 2D and 3D side by side. I don't want to have to switch between those two tabs. I can grab on one of those tabs at the top of the screen here. So I'm just left mouse clicking and dragging. It then brings that out as a separate window. So I can either drop that as a separate window and put it on a second screen, for example. I have the two screen setup, or if I want to snap it to another area of the actual master window, I can use these options at the bottom here. So you'll see I've snapped to the bottom, right, top, right, bottom, and left. And there you see we've been able to split the screen. And you can split this as many times as you wish. Obviously, it gets a bit confusing if you have too many screens showing, but you've got full customization over this. If you then want to reset your screen to how it normally would be, underneath the view drop down at the top of the master window, there's this reset display option, which just takes you back to normal. Okay, so the next thing I want to show is the ability to multi-select boxes within master. So you'll find this in many, many places, but whenever you see sort of multiple selection boxes in editors or various different areas around master, you will be able to multi-select these and put items in there all at once. So let's say, for example, I'll do a couple of examples of this. If I go to edit one of my shaft profiles, you'll see at the bottom we have our profile point details. However, if I want to modify more than one of these at once, so let's say those 2 points there, I could highlight both of those boxes. And if I type the number in once, it applies it to both of those. And that applies to anything within, say I can highlight as many of those as I wish, put in that value, and it will put those in all at once. So let's say for the inner profile there, if I wanted to get rid of that inner profile completely, I could grab all of those diameter boxes there, put in a 0, and it will adjust those all at once. The same thing applies with checkboxes as well. So let's say I wanted to actually apply a fillet radius to all of these at once, for whatever reason. If I select all of those, if I enter a value in there, it will activate those. And I can click on the enter key to actually apply a value in there. It's not doing it in this case because of my specific geometry. However, the spacebar will activate and deactivate these, and then I can add in a value. So this also works in other areas. So let's say, for example, on a load case, So if I add a few load cases in here just to demonstrate and go to my design state, you can see I've got numerous different load cases applied. So let's say I wanted to apply the same speed to all of these. I could select all of those, click on my spacebar, and then enter a single value, which will apply to all of those boxes. It's just a way of saving you time, basically. Okay. So the next thing is something on the 3D window. So this is the ability to clip the 3D view and to auto align, essentially. So basically switching the orientation of the view. So if I right click on my 3D window, I have a few different options available. Most of these allow us basically to adjust the view slightly. So I can either zoom the model to fit or change the orientation to a certain set of the axes there. I can also save a current image on the screen if I so wish. Very handy if you're making presentations based on master models, for example. And I also have the clipping option down here as well. So this is a very simple option, which basically allows you to cut through your master model. So basically you specify an axis which you want to cut through using this global coordinate system. Move this slider to say where you want to cut this. And it basically just allows you to see through your master model. You're very useful if you've got components within other components. Let's say a planetary gear set, for example, to actually see where things are sitting. So let's say there, for example, I can then see inside of my bevel differential. So the last point on the general user interface is the ability to copy data from graphs. So wherever you see a graph within MASTA, or even a chart a lot of times, you will be able to actually export that data directly. So let's see if I can find an example. If I go to my microgeometry, let's say. Okay, so I'm going to go to my microgeometry chart where hopefully we've got something specified. So I've got my lead modification and profile modification charts. I can right click on this and copy that data to clipboard, and then I'll be able to just paste that into Excel and manipulate that however I wanted to do. However, that isn't the limit. So as well as that, I can do this on 3D plots as well. So let's say my total modification chart, for example. I can right click on that and copy the data to clipboard. And then hopefully we can open Excel. And it will give us a detailed plot of that variation. So the points it's used to actually generate that chart. And that can be utilized in many, many different areas within MASTA. Okay, so going back to the design, what I want to show you next is a few points on the design itself and things that might save you time when you're actually creating a design within MASTA. So the first thing is positioning components. So if I go on my Move Components tool at the top, what you'll see if I select on any component is that down at the bottom of the screen, we have a chart which gives you an image of the component to be moved and the component it's connected to, and then how the component relates to the things it's connected to. So for example, this particular shaft has connections to this concept spline here. It has this bearing here, and this power load. And you can see those 4 entries in this table. Now, if we wanted to move those relative to one another, we could just grab one of those components and drag it manually. However, if we wanted something a little bit more exact than this, so let's say we wanted this bearing to sit flush with the end of this shaft here, I can do this using this table at the bottom. So if I selected the bearing, because that's only got one connection to the shaft, I've then got options in my table which say what I want to connect which point on which component I want to connect to another point on the connected component. So if I say, for example, the rotor shaft here, I want to connect it to the right-hand end, and you can see a little indication of the actual area it's measuring here. I want to measure that to the right-hand side of the bearing. You see it's done the same thing again. And then I simply put a value of 0 into here, and it will make sure my bearing is flush against the right-hand edge of that shaft. You should also be aware that you can multi-select options in here as well for movement. So the same way as you would in sort of Windows Explorer window or something like that, where you can multi-select files, you could just multi-select items in here. So we can box select by holding down Control. So if I hold down the Control key and drag over a bunch of items, anything that's completely encompassed within the box I create will be selected and can be moved as one, so their relative positions won't change. I can also multi-select, so by holding Control down and clicking various components, and then move those all together. Or if I've got things all in their individual assemblies, that's quite useful for us to view, I could just click on an assembly. It will show us the associated components, and I can move all those as one as well. Okay. So the next thing is an option called drawing view position. So chances are that you won't have to use this one very much, but it can be very useful when you do need to. So sometimes when MASTA's trying to create a 2D representation of your 3D model, you may find that it gets the positioning of some of the shafts slightly wrong. It can only view them on top or below other connections at this point. So based on your 3D model, it will have its best guess, but it might struggle a little bit. If you want to actually change how these things are viewed, there is a property which is located on the actual mesh of a gear set. So if I select my gear or an associated gear set, go to the mesh icon, and then we have a drawing position option. And this basically tells us whether we want to position the current, or which orientation we want to position the current drawing. So at the moment it's on auto, which is pinion above wheel. So if I select this, it shouldn't change. However, if I change this to be wheel above pinion, it will snap it down to the bottom. Or I could tell it to draw them separately as separate parts of the assembly as well. Now you may think in this model that's slightly useless. However, when you are developing your models or drawing them relative to a background DXF or something like this, having this ability to actually position the shafts as you wish to view them can be very, very useful. Okay, so the next little time saver I have is the ability to automatically or to quickly create a gear blank assembly. So I'm going to open up a new model to show this. Okay, so we'll use this as an example. And what we'll say in this particular example is that we don't want this gear to be part of the shaft. As this is modeled at the moment, it essentially thinks that shaft and the gear are the same component. As the gear component is directly mounted onto the shaft, it's essentially as if it's manufactured from the same component. If we wanted this to sit on a bond or a spline or a bearing, we could do the whole thing manually by manually creating a bearing component, another shaft component for the blank and connecting them all together. Or we could use the create gear blank assembly option. So if I click on my gear and then right click on its item in the assembly tree up on the top left hand side, you'll see that we have this option for create gear blank assembly. It's a very simple explorer, this, which adds up a new, or loads up a new window and basically allows you to select the item that you want to put in the middle. So it automatically creates a new shaft component for you to represent the gear blank, and it creates some component that you specify underneath that. So your options are bearing or shaft hub connection, which could be a rigid bond or a spline or an interference fit. Then you've got some geometry functionality for these, so you can specify the geometry of these connection points. And if you wish, you can apply some thrust pads to this as well. So if you want to give this some axial clearance, let's say there's going to be no axial stiffness on this component, you can add those components in automatically and specify the clearance that's on those thrust pads, so how far it can move either side. You click OK, it makes that assembly for you and saves you the hassle of having to make all of those components manually. Okay, so next up is the center distance editor. So you won't see this unless you try to adjust the center distances of your gears, and MASTA doesn't know which one of those is supposed to be fixed in place. So if I go to my gear set, for example, and I'm going to see if I can find my center distance property. I could find it in the editor, but I can also get in the properties window. Let's say I want to increase my center distance between those gears. If it doesn't know which of those shafts needs to be fixed in place, it will come up with this window here, which is the center distance editor. It works quite simply if you've got a two shaft setup. It will also appear if you've got a more complex situation, like a planetary gear set, for example, or multiple shaft setup where you need to move things relative to one another. You'll basically have a list of the available gears in the mesh, gears in the gear set here. You select which one of those are fixed in place. So let's say in this case, we want to fix the pinion. And then we can move the remaining 3 gears relative to that fixed pinion. So it gives you an indication on the right-hand side of what this option does and where that will move to. So I can either put in a value up here, or my suggested value, which I entered, was 120. I can fix that, click OK, and it will adjust that center distance. Now it knows which one of those shafts is fixed. I can just enter the new center distance any number of times, and it will reposition automatically because it knows which one of those shafts is fixed in place. Okay, so the next thing is quite nicely leads on to auto fixing the gears. So if I go to my 3D view now, the gear geometry has stayed exactly the same based on, well, stayed the same when I changed that center distance between the 2 gears. However, that obviously has broken the gears. It's no longer a viable gear set because I've not changed any of the geometry. Now, obviously, you're going to want to do optimization on your gears and that kind of thing. But if you're at a concept stage, you might just want to get a gear set which is viable, so which is able to transmit torque and is a reasonable gear. And it's a very quick way to do this using MASTA. So if you've got a gear set which is broken, you'll notice in the status window at the bottom here that we have a number of errors popping up. And these are all to do with the gear set that we have selected. And there's various different ways we can fix this. The bottom option with the click button there will basically allow you to change things like the tip and root diameters and the center distance for the gear set to get a reasonable gear set. So the chances are with this one, it would reduce that center distance back to what I changed it from originally. However, if I was happy with my new center distance and wanted to change the other aspects of the geometry, I could click on this find by fix or fix by find option at the top, and it will try and give me a number of different options. In this particular case, it's giving me 2 solutions. It's saying I can either adjust my normal module for my gear set, or I can adjust my normal module and change my profile shift coefficient. It might come up with numerous different things in there dependent on your design. So if I click on one of these, for example, think I've still got clipping on there, which I can turn off. You can see that it's changed my gear geometry, and it's now a viable gear set with no errors included. It doesn't mean it's going to be a perfect gear set, as you can see. There's a lot of work to be done, but it's okay for a concept stage as we can actually continue working on this. Okay, so the next thing I want to discuss very briefly is the ability to use cutters in design mode. So I think this is quite a little known thing that was added to one of the recent installations of, or recent updates to MASTA, maybe MASTA 9. And even without the manufacturing modules within MASTA, you can, on the editor of a gear set, over on the right-hand side, you have got the ability to use a manufacturing configuration for your cylindrical gear cutting option. So by default, your gear set you create in MASTA will probably use a basic rack specification. However, if you have some cutters specified, for example, you can use them in here and the gear tooth geometry will represent those cutters. So for example, if your cutter and your current gear geometry means that you'll have a notch at the root, it will show that within the window, within the MASTA model, and you will actually see that as part of your analysis results as well. So I'll keep this quite simple. I'm just going to create cutters based on my current designs. You can say I'm using manufacturing configurations there. You can add your own rough cutters and finish cutters as well. So if I click on these, for example, loads up my cutter database, so you can add new entries to there. And it will give you any warnings or errors if it can't manufacture the current gears based on those cutters. Okay, now I am gradually screwing up this model, so I'm going to keep opening up new instances of it to make sure we can still do things. Okay. So one last thing on the gears here is the properties, which means to maintain the transverse profile. So you'll see a few of these when you go in the gear editor. But what it basically means is that you can adjust some aspect of the gear geometry, and it will actually modify some of the transverse properties to maintain that transverse shape. So it means that, for example, if I changed my helix angle, it would change other things as well as just the helix angle and make it so you've still got a viable gear set. So I can demonstrate this. So if I split my screen, I'm going to use these two properties here. There's a few properties which have maintained transverse profile. This is just one example. If I change my helix angle just on the helix angle box, so let's say from 30 to 15, that is going to break my gear because it's the only thing it's changing is the helix angle. If, however, I put this same value in helix angle maintaining transverse profile, you can see it's modified that helix angle, but it still has a viable gear set because it's had the ability to modify additional gear geometry. Okay, so we have had a question come in about the orientation of gravity, essentially. So I will just show you a little thing as to how we can actually change the orientation of gravity within the model based on your preferred coordinate system. So if I go to my 2D view, and on the top level, so my root assembly, this in the properties list is where you will find the sort of system level settings. So things like gravity orientation, things like specification of lubrication, required safety factors of components, that kind of thing. So if I go down here to gravity orientation, we can see we have some components for gravity. So by default, we have it specified in a negative Y direction. However, if you wanted to see something different, I could just change the vectors and it changes that orientation of gravity within the model. Okay, so the next thing I want to show you is configurations. So configurations is basically a way of having different setups of your model within the same master model. So if you go to your top level in your design mode, you'll see that there's a configurations table or configurations report available in the editor dropdown. And then it has a number of different tabs. So gear configurations, shaft, bearing, and imported FE. Okay, so if I say, for example, I want to add a configuration for the gear set, which is configuration 1, a second called configuration 2. Now I could select different gear designs here. So I could say, for example, this is my macro geometry design selection and my micro geometry design. Let's say my configuration 2, I want to be a slightly different macro geometry design. I could then select between those two configurations at will. And you can see on the right-hand side that the geometry is actually changing for these. So it means we can switch between different designs quite easily. And the same kind of situation applies for the other components. So shafts, bearings, imported FE. Can add in different configurations, and it will allow us to change the different setups of those particular components. Okay, so the last thing I want to point out on design is to do with gear fit systems. So this is basically to say that as a default setup for MASTA, you will have a gear fit system enabled on your specification of any gear. And this is basically so you've actually got some scope to play around with the geometry and it will still maintain a reasonable gear shape. However, you may want to change this or you may want to turn this off. It's up to you. Just to show you where to find this, if you select your gear set and go to any of your tooth thickness tabs at the top there, and if I'm on my profile shift coefficient tab, you'll see for this demo model it's been turned off, but you will usually see the specification of this DIN gear fit system, for which you have various different tolerances and allowance properties. And that will restrict access to a lot of the different property values. So it'll define a lot of the tooth thickness properties for us to allow us to get a reasonable gear that allows us to transmit torque. However, we can turn this off if you wish, which gives you much greater access to the options down here. So I could then get rid of my selected options on a certain gear with the gear fit system turned off, and I've got access to all of these other tooth thickness specification options. So next section is to briefly talk about some little hints and tips in terms of FE models. So again, I'm going to use one of our simple example models for this. A very simple one, so I do apologize. So this is the simple housing model, which has a full FE mesh available for it. Okay, and the first thing I want to do is show how within MASTA itself we can change the grounding of faces and nodes within the model. So by default, if I turn this option on up here to show grounded nodes, we can see that this bottom face is the one that's grounded. Now let's say for the sake of argument that I didn't want that one to be grounded anymore. I wanted my grounding face to be on here, for example, or either side of this particular extrude. I could go to my element faces tab at the bottom here, and you can see there's an option just underneath there which is to ground or unground faces. So what I want to do for this is to actually select the elements that are of concern in this particular case. The ability to select elements or nodes is done on the top right of the screen here within this selection region. And I can say that within this drop-down, I want to look for a surface, highlight my particular surface so you can see it's got that entire bottom face, and remove that grounding. And you can see those red nodes now disappear, and it means this is completely ungrounded. If I then want to apply it to a different section, let's say these bolt holes for the sake of argument, I could select those, click on ground, and it will ground the model at those points. It's done the bottom again because I still had that selected, unfortunately. There we go. Now, the same kind of functionality applies to the creation of condensation nodes. So this is something that was added in for the MASTA 10 release, and is really if you want to do some MVH analysis where you want some condensation nodes to match the location of accelerometers in your model, for example. So let's say you had a something running on a test bench and you had some accelerometers for MVH analysis. You want to simulate measurement points at that exact same position in your FE model. Now you could select an individual node if you so wished and change that into a condensation node. However, a more realistic scenario might be to select a range of elements and connect them all to one condensation node, as the accelerometer will cover a larger region. So if I go to my condensation nodes tab here, and what I want to do is select a few elements where my accelerometer condensation node is going to be. So instead of the entire face this time, I want to select, or instead of the entire surface, I want to select the face. Which is slightly confusing terminology, I admit. And then I'm going to select the associated elements that I want to connect to a condensation node. And I want to make sure that I don't keep this one selected. I keep falling for this. Okay, so select those. We can see I've got 6 faces selected. And when I create a condensation node, we can see it makes a condensation node on that particular surface and connected to the nodes that are associated with those particular elements. Because I've created this, I've now got the ability to adjust its position and to define whether or not it's a kinematic coupling or a distributing coupling. So an RB2 or an RB3 coupling. Also within the FE window here, we do have the ability to change the material properties of the FE components. So this is useful if you don't want to go all the way back to your FE package to set the material back up again and export it. So if I'm in the FE mode, go to my FE model details over on the right-hand side and the materials tab. You'll see that in this case, there's only one entry because this thing is all the same part and all the same material. However, it does give me access to the critical properties for stiffness. So the things that MASTA will actually use for this component stiffness. And see, I can select the nodes to identify which component that is. In this case, it's all one. And then I can modify density, elasticity, Poisson's ratio, and thermal expansion coefficient. If there was multiple components in this piece of FE, it will come in as separate entries into this list here. I could select the different components to ensure I've got the right one, and then change those material properties at will. Okay, so something that was brought in one of the latest releases, MASTA 9, I think, was the ability to actually mesh a shaft profile. So if you wanted to create an FE model of a gear blank, for example, and it was exactly the same as the MASTA Timoshenko beam was modeled. So let's say, for example, we want to replace this with an FE model, as the Timoshenko beam won't capture the flexible behavior of this blank. We could create a mesh of this particular setup. So if I go to my imported FE mode, I'm going to add a new FE component, which is going to be related to one of my shafts. And then I do this under my import or export tab. So where I would normally import my stiffness matrix or my CDB file, for example, as well as full FE mesh and externally reduced FE, I have this create shaft mesh. If I then move forward to my replace shafts, I need to specify which of these shafts I want to replace with FE. Okay. Then I move forward to meshing options, and it's basically giving me options for controlling the mesh density and the mesh shape, or the element shape and the element order. So you can play around with these as you wish. And then when you're happy with the selections of these, so where it meshes up to, the size of the element, you can mesh volume, and it will actually create that for you. So you can see there that up until the root diameter, which is the thing we've specified, it's actually replaced that shaft and its associated connected gear blank with an FE component. So once we actually generate the stiffness matrix for this, which I won't do now to save time, we do have the ability to save these files externally. So what you may find is that when you start creating different FE components within your model, the model size will start to get up or start to increase pretty quickly. And then your saving time increases, your loading time increases, and it's just not necessary really. So what you will see is this ability to import and export or export mesh and vector files. So basically when you have this generated, you can click on the store or the export here, and you can save that externally. What it means is that when you open the model, it will load those in. And then basically it just considers those loaded then. It doesn't need to actually resave those again. So if you save the component after that, it will just save the actual model itself, the actual master model, rather than having to resave that FE every time. Okay. So the next section I want to go on to is covering some of the hints and tips on the reporting options. So the reports in MASTA are very versatile. So let's say I'll go on an analysis report, for example. That won't work because I've messed the model up. Okay, so if I run something through in system deflection, and go to my reports, you'll see that we have a report format demonstrated to us. However, this is just the default report that MASTA shows you. So this is trying to summarize all of the information you could possibly need for the particular component you have selected. So if I have the root assembly selected, it's going to show me all of the results for all of the components at quite a high level. If I then drill down into my gear set, it will show me specific gear set reports, that kind of thing. Now, chances are there's too much information in here. There's more information than you need. If you want to create a custom report format, you can do so within MASTA. You can create a complete custom format if you wish. Or let's say you simply want to do a quick edit of the reports. So let's say you wanted to add just 1 or 2 properties into the reports. So for example, I'm on a gear set here. If I go to my gear mesh misalignments tab, and we might want to add one of the other type of misalignments in here as well. So let's say rigid body misalignment or line fit. If I go to this edit button here at the top of the specific table I am using, it will give me quick access to the properties in that particular table. So instead of having to go through the whole process of creating a report, creating a table, adding all of these properties in, I can just jump straight to the properties for that particular report. And then if I want to find associated properties, similar to the misalignment, for example, I can find it in this list in the middle, which is my properties, double click, and it will take me to that point within the properties tree, and I can find those associated properties quite quickly. So I can say, for example, I want rigid body misalignment and line fit. And I can very quickly add those to the reports. It saves me out a copy of that default report with the new properties available. And that's now a report that's saved on your machine. So any model that you have open or any gear set that you view, those properties will now be visible. It is also possible to import or export report formats. So if you put in a bit of effort to actually make the report format to suit you or your company, you can export those formats so someone else can just bring them into their machine and everyone can see the data in exactly the same format. So this is done in the edit menu at the top of the screen. There's a section there for custom reports. And then you have these options here for import and export. If I export a report, it basically asks me where I want to get that custom report from. So it shows me a list of our custom reports. So this is the one I just made, for example. Click OK. It allows me to save this to a different location. And then I could share that with my colleagues who could then import it into their own model. And it's an easy way of sharing report formats between a company or with contractors or anything like that. So everyone can view things in the same format so you know where everything is. Another useful thing is the ability to actually pop out a static version of any report that you're looking at. So let's say, for example, I wanted to compare this misalignment value here to the misalignment of another load case. I could press this button here, which opens report in a new window. And this report that it opens up is a static instance of the report. So this now won't change depending on whatever else we choose. And I have it selected at the moment to always stay on top. So if I then go into my main master window and run another load case, I can see that this is updating. So I have my new misalignment model. However, our report on the right-hand side is still static to what it was. So we could do a direct comparison between the two for any of those properties in that report. We also have the ability to save reports out externally. So if you didn't want to just copy and paste the data elsewhere, you could click this save icon, which allows you to save in various different formats. And then the last thing I want to show on reports is, or kind of associated with the reports, is the file history and comments. So when you go on save a file, okay, when you go and save a file, you do have this history item. And what this basically gives you is the ability to actually add a list of history changes to your particular master model. So viewing the history will show us a list of potential changes. However, in the actual save window, you'll see here that we have the ability to actually add to that report as well. So for one, we can specify the current user, and then we can specify some comments. So this is useful if you want to actually keep a running change log of what's going on in the model. So if you're looking for potential things that have changed between the last time you opened the model or changes that multiple users are doing to the model, you can put a comment in here every time you save. It then adds it to this list of history items at the bottom, along with a version of MASTA, just in case there's been a change in results per version. It adds a unique hash code for that particular setup of the model. And then as I just showed, if I just put something in there, that then gets added to our history item. Okay, so just a couple of points to finish off to do with the loading conditions and analysis. So just a couple of small things. One is the ability to change multiple load cases at once. So I can here, for example, I have numerous load cases available in my model. If I went to my load cases and duty cycles tab, yes, I have access to all of these. However, there's a lot of cases where I might have to change these things individually. So let's say I wanted to include gravity on every single one of these load cases, which is quite feasible. If I was doing this in the load case screen, I might need to go through every single one and click on this gravity option here. However, if I wanted to do this for everything in one, rather than having to go through individually, I could go to my power flow or system deflection, click on the design state duty cycle I want to change, and then within the properties list on the top level, you can see I can access my load case settings. So I could say I wanted to include gravity for every load case within that design state. And then it will select that automatically for every load case within there, rather than having to go and do them all individually. And then the last thing, which I've kind of been doing anyway, is the ability to duplicate designs. So if you wanted to do some direct comparison between alternate designs, for example, you could open up different iterations of the design along this ribbon on the left-hand side. So let's say, for example, I wanted to run this load case through and do a comparison with another slightly different model. I could duplicate this design by right-clicking on its tab on the left-hand side. That gives me a carbon copy of this model, which I can then modify as I wish. So let's say I've modified the geometry or something. Run that again, and it would allow me to do a direct comparison between those two different models.